All right, so we've talked about what a random variable is, what is a discrete random variable, what is a continuous random variable. Today we're going to create a probability distributions. Okay, now we only do this for discrete random variables because as we talked about yesterday, discrete random variables you can count. Continuous goes on to infinity and it's infinite and it's not finite, so we cannot count it. So we do not make them for those, okay? So a probability distribution displays all the probabilities associated with all possible outcomes of an experiment. So an example, this example is going over when you flip a coin. I want to flip a coin one time and I want to count how many tail, or what's the probability of me getting a tail. Okay, now there's only two sides to a coin. You're either going to get a head or you're going to get a tail. But since we're just talking about tails, your outcomes are either you get no tails, or you get a tail. That's it. That are the two outcomes that can happen. Okay, because we're talking about tails. All right, we're not talking about heads, we're just talking about tail. So I can either get a tail or I'm not going to get one. So that is what my table is talking about. So this is our random variable right here. This is where you put the random variable. And then when you see P of something, it means the probability of that. So this is the probability that I get whatever this random variable is talking about. So my random variable options are I get 0 tails or I get 1 tail. Now a coin, it's half and half. So the probability I get no tail is 50%, and the probability I get 1 tail is also 50%. Okay? That is what a probability distribution looks like. Now, one thing you really need to know, a probability distribution, the probability always adds up to 1. Always adds up to 1. 1 or 100%. If it's in percent form, it adds up to 100%. If it's in decimal form or fraction form, it adds up to 1. This bottom row always has to add up to 1. If it does not add up to 1, then it is not a probability distribution table. Okay? So that leads into our next section that we're going to do. Before we start creating ones, I want to determine if a table is a probability distribution or if it's not. Okay? All right, so I want to determine if the following are probability distributions, and if not, I want to explain. Well, the only way they're not going to be a probability distribution is if they don't add up to 1. Okay? This is saying that the probability, P of X, has to add up to 1 or 100% if it's in percent form. Okay? So we actually don't care about the top when we're doing this. If we're determining if it's a probability distribution, the bottom needs to add up to 1 or 100. So what we're going to do is we're going to add this bottom row. Fractions, you just add the numerators. So I'm going to say 4 plus 2 is 8. No, that is 6, isn't it? 4 plus 2 is 6, 7, 8, 9. So this adds up to 9 over 9. Well, what does 9 over 9 reduce down to? It reduces down to 1. So yes, this is an example. Okay? All right. Number 2, we're adding up the bottom row. It is fractions again, so we're just going to add that numerator. 3, so 3 plus 1 is 4, then 5, 6, 7, 8, 9, hold on, let's see, 6, that's a 4, 5, 7, 10. So this is going to be 10 over 10. Right? Let's see, 6, 8, yeah. So that adds up to 1. So yes, this is also an example of a probability distribution. All right, number 3, we're going to add up these decimals, and they have to add up to 1. 1.1, that's going to be 0.3, 0.6, that's going to be 2.5. Well, that's over 1, isn't it? So this is not a probability distribution, which you really could tell that by just looking at this first one. That probability by itself is already 1, so it would make this null and void. Okay? So that is how you tell if it's a probability distribution. Those probabilities, the P of X's, they have to add up to 1. And if they don't, then it's not a probability distribution chart. Okay? All right. So now let's actually go to how to create. We're going to create a chart. Okay? I'm going to give you a scenario, and then we're going to create it. Okay? So number 1 of creating, it wants me to make a probability distribution for one roll of a 6-sided die. Okay? So we know we're going to have our X over our P of X. Okay? Now, our X is like, what are we talking about? We're talking about rolling a die one time. and it's a 6-sided die. Well, X are all your possible outcomes. So when I roll a 6-sided die, what are my outcomes? What can I roll? Like what can happen when I roll a die? Well, I could get a 1. I could roll a 2. I could roll a 3. My line got a little crooked there. I could roll a 4. I could roll a 5. Or I could roll a 6. So those are all the things that I could roll when I roll a die one time. Okay? Now we have to find the probability of that. When in Math 2, you learn about probability. It's what you want over everything you have. Well, all of these have the same probability. When I roll a 1, how many 1s are on a die? There is 1 1 on a die out of how many total numbers? 6. There's 1 2 out of 6 numbers. There's 1 3 out of 6 numbers. There's 1 4 out of 6 numbers. There's 1 5 out of 6 numbers. And there's 1 6 out of 6 numbers. And you can double check it. That'll add up to 1. But there's your probability distribution table right there for that one. Okay? So if you had a 12-sided die, you would just change it to 1 over 12. Okay? All right, let's do another one. So now I want to make a probability distribution for one spin on this given spinner. Okay, so we're going to make our chart X over P of X. Okay, so first I need to know what outcomes are possible. What are the possible things I could get when I spin the spinner? Well, I could spin a 1, I could spin a 2, and I could spin a 3. That's it. That's the only outcomes that I could have off the spinner. So I could spin a 1, I could spin a 2, or I could spin a 3. Okay, so those are my outcomes. Now, remember, probability is what you got, is what you want over what you got. Well, there's a total of 8 sections. Okay, there are 8 sections on this spinner. All right, that's going to be my denominator. So how many 1s do I have on this spinner? I have 2 1s on this spinner out of 8 sections. 2 1s out of 8 sections. 2s, how many 2s do I have? I have 1 2 out of 8 sections. And then how many 3s do I have? I have 1, 2, 3, 4, 5 3s out of 8 sections. And that's my probability distribution table. Okay? Now let's do one off of scenario with percents that I give you. All right, so here's a scenario. It says, from past experience, a company has found that in a carton of transistors, 92% contain no defective, 3% contain 1 defective, 3% contain 2 defective, and 2% contain 3 defective. I want to construct a probability distribution about this scenario. Okay, so we know we need our X and our P of X. So our X is obviously talking about defective transistors. I'm having difficulties with that word, or am I not? Okay, so that's what it is. So I need to know the outcomes of how many defective ones I can have. Well, when we read it, it says 92% have no defective, so we could have no defective in a package. We could have 1 defective in a carton. We could have 2 defected, or we could have 3 defected, okay? So those are the possible outcomes I could have in a carton of defective, all right? Now, it gives me the percents of each. It says 92% contain none, so I'm going to put 92% here. It says 3% contain 1. And then it says 3% contain 2. And then it says 2% contain 2. And that would be my chart. Okay? All right, so that is it. Your worksheet's going to have very similar examples. Your worksheet's going to go over, is going to have how do you tell if it's a probability distribution and how do you create one. Okay? So let me know if you have any questions. And that's it for this video.